Hello, my name is Koteshikawa. I'm starting my presentation for SIT742 Task 1 Part 2. In version 1, I will explain the linear optimization code in question 2.1, run it and confirm the optimal solution. Then in question 2.2, I explain an application to the IT field, specifically a resource allocation scenario in cloud computing. Program overview. We want to maximize 3a plus 4b constraints a plus 2 times b must be less than or equal to 14, b must be greater than or equal to 3, a must be less than 15 and b must be less than 15. Since a and b are integer in a small large, we can find the optimal solution by brute force. First, import code explanation. First, import numpy. Define the search range for a and b. A from 0 to 14, b from 3 to 14. These come from the constraints. The objective function is function a, comma b equals 3a plus 4b. So we store the confidence as arrays 3, 4. We create variables to store the maximum value and best solution. Then we loop over all combination of a and b. For each pair, we check the constraint a plus 2 times b must be less than or equal to 14. If it is satisfied, we calculate the objective function value and operate with the maximum if it's larger. Finally, we print the optimal solution and value. Results: running the code give a code 8, b is 3 with an objective value of 36. This makes sense. The smallest b satisfying constraint gives the most room for a, maximizing sale. Application 2.2 application scenario. Example in IT is CPU core application in cloud computing. Multiple applications share limited number of CPU cores. Maximum goal is maximize performance without exceeding available cores. Variable x equal core for application 1, x equal core for application 2. Object function 5x1 plus 4x2, performance again per core. Constraint x plus x2 must be less than or equal to 16. X1 must be greater than or equal to 4. X2 must be greater than or equal to 2. For small program, brute force like question 2.1 work. For larger one, the simple algorithm or SPI optimizing probe is efficient. Evaluation and conclusion. Advantage: linear optimization advantage is guarantee optimal solution and constraints, handle large scale much variable problems. Limitation: object function and constraint must be linear, sensitive to coefficient estimation errors. Possible improvements: dynamic optimization with runtime monitoring. The approach in question 2.1 for product sale can be applied to cloud source allocation, ensuring fair and efficient use of limited resources. That's all for my presentation. Thank you for your attention.